convert assembly program to object program, that is a two-pass assembler in SIC. For this, the tools required are Linux-based operating system and a G++ compiler for the compilation of the program. The prerequisite knowledge required before going through the video is: what is an assembly language? An assembly language is the most basic programming language for any computer. What is an object code? The code produced by a compiler or an assembler is called as object code. What is an assembly language program? An assembly language is a low-level programming language for a computer or other programmable devices, in which there is a very strong correspondence between the language and the architecture's machine code instructions. A program made in such language is called an assembly language program or a source program. It is converted to an object program by an assembler. Any instruction written in assembly language consists of three parts: a label, which represents the symbolic address of the instruction. The operation field specifies the operation to be performed. The operand consists of the symbolic address of the memory location. The comment field is used for the purpose of documentation. Here is a simple example of SIC assembly language programming. As you can see, it consists of few assembler directives which are not converted into machine instructions and are used to provide instructions to the assembler itself. For example, start, which specifies the starting address of the program. What is an object program? Object program is a computer program translated from the equivalent source program into machine language by the compiler or assembler. Example of object program. The simple object program format we use contains three types of records: header, text, and end. The header record contains the program name, starting address, and length. Text record contains the translated instructions. The end records marks the end of the object program and specifies the address in the program where execution is to begin. Now, let's see how to make object code corresponding to the assembly language program. As you can see, there is a new column named LOC, which gives the machine addresses for each part of the assembled program. We have assumed that the program starts at address 1000. The translation of source program to object code requires us to accomplish the following functions: convert the mnemonic operation codes to their machine language equivalents. For example, as you can see in line 10, STL is converted to 14. Convert the operands to their equivalent machine addresses. For example, convert RETADR to 1033. And finally, build the machine instructions in the proper format.
Now let's see how the program, that is the two-pass assembler, works. The program works in two passes, that is pass 1 and pass 2. In pass 1, scanning of the assembly program, address generation and making of SIMTAB takes place. Following it, in pass 2, object code is generated and then finally the object program is created. Now let's get us a look of the program. We read the assembly program file assembly.txt word by word here. and single space is used as the delimiter here. For every empty column field, user is required to place 4 asterisks in place of it. Now, basic idea of the program is to initially read the file and simultaneously store it in a table-like arrangement. Array of this structure assembly is used to store the assembly program for use in future by the 2-pass assembler. Similarly, array of structures simtab and optab are used to create simtab and optab. Now let's see the main of the program. Here, main has 4 functions, namely insert optab, pass1, pass2 and output. First function is the insert optab. This function performs the creation of the optab, which would be used later by the program to create the object codes. Pass1 function. In the beginning, assembly program file is opened in the read mode. While reading, for each record, we will be checking if mnemonic is valid or not, along with address generation. So in the while loop, till the program does not end, we start from reading the label of the record. Then we check whether it's a comment line. Being comment line, comment is read in comment column and rest column are left empty. If it's not, we read the mnemonic and now check initially if it is start. If it is, then the operate part is assigned to PC and the starting address and the location is initialized to 0. Now for every program command, rather than assembler directive start, it reaches to this part of the function. Address is assigned for new record as that of PC. Here literal function checks if it is a literal defining statement, and if it is handled for byte as this, for word, reserve word as this, for reserve byte as this, and for word as this. If it is neither of above, then the operand is simply read of the program record into the operand column and the piece is incremented to 3. Now we check if it is a literal defining record. Is literal tells if it is a literal or not. If it's not, then the mnemonic is checked if it is present in the optab or not. Opcode in optab function performs this task and error is printed for invalid mnemonic and the compilation is halted by the exit statement. On mnemonic being valid, the loop begins again and the same process repeats to read a new record. In the end of pass1, make my simtab is called upon to create the simtab. In make my simtab function, we scan the label column of the assembly program till the end, and for each record, check if the label is there using the function label exist. Label exist check if it's neither an empty field that is denoted by 4 asterisks nor a comment line which is denoted by a single dot, and if it is so, it is a label. For literals, value is also stored in the simtab along with the label name and its address. Pass 2. Here we initialize the array of object codes which we named as instruction code. Object codes corresponding to each program command line will take place till we get end in the mnemonic column, that is till the end of the program. For program command lines, object code is generated, and for literals, value is to be copied in the memory. So we firstly check if it is a program command record by the function opcode in optab. If the opcode is there in the optab, then it is a program command line. Then assign opcode assigns the opcode of the mnemonic from optab, and assign address assign the address of operand from the simtab. This is how the object code is created. Now indirect function checks if indexed mode is there. If it is x bit becomes 1, change of 8 in third character is there in the object code. Now, if it is a literal, then value is directly assigned to the memory by the function assign value. If the above two cases are not there and label is EOF, that is end of file, then the hexadecimal equivalence is copied in the memory. For the last two cases, that is assembler directives and comments, null is assigned to the object code.
Pass 1 and pass 2 are already explained. Now let's talk about the output function. Here is our output function. In it, print syntax function will print the previously generated syntax. Here is the label and their address and their values. Now let's come to the next part of code. This command will print the header of the tabular form, location, label, opcode, operand, object code generated, and this loop will print their corresponding values. Let's say it on terminal. Here it is, location, label, opcode, operand, and generated object code. In this code, index addressing mode is indicated by $x following the operand. Now let's see an example. As you can see, it is an index addressing mode as $x is here. So now address generated would be 1039, as the buffer have address 1039 and the 1 bit of x, which equals to 8000 plus 1039. So the object code generated would be 549039. Now let's see our next code. This is how object program is printed. This code will print the object program on terminal window. Let's see it here. This is our object program. Object program consists of 3 records: header record, text record, and end record. Header record starts with capital H, and then the name of the program comes, which is copy in our program, then the initial address, and then the length of the object program, which is 107A. This is just a difference between the final address, which is 207A, and the initial address, which is 1000 in our program, equals to 107A. Text record starts with capital T and then initial address of the program, then the length of the object text record will be right here. Same goes for all. Now in end record, it starts with A, and then E specifies the end record, and the address of the first executable instruction in object code is printed right here. This is how object program is created. Now let's see what will happen if we provide a wrong assembly text file to our program. So let's create a new text file and and copy a wrong assembly code from right assembly code. We are changing a spelling. It is a spelling mistake. LD is now LDF. Save it as assembly2.txt. Now let's save it. Change this address in our program. Change assembly.txt, which is right assembly program text file, to assembly2.txt, which is wrong, and we are having a error there. Let's see how a program will take is g++ project.cpp a.out. As you can see, there is error in line 4, mnemonic LDF not found. This is how our program takes the error if there is any error in the assembly file. Now let's see what will happen if we will provide a correct assembly program text file. Let's change it to again to write program file and run it again. Compile it. G++ project.cpp, which is the name of our project file. Dot out. As we can see, our program is running smoothly. SimTab is created, tabular form is created, and object program is created. Thank you for watching this video.